Hello, and thanks for clicking on this next Prenarculus production. Today, we are going to talk about how to find the average rate of change of any function, which sounds very, very complicated. Sounds like a lot of work, but to be honest with you, you pretty much already know how to do it because average rate of change is something that you've calculated in Algebra 1, in Algebra 2. You probably did it in the middle school. So let's get started and talk about what average rate of change is and how we can do it. So we're going to calculate the average rate of change. The average rate of change is just the slope of the line through two given points on any given function. So now what I'm saying is you don't have to have a line anymore. You could really have any function that you want. So here's a parabola, a quadratic function. And let's say I picked 2 points. I picked this point here, and I called it A. This is the name of my function, f of x. And this point here, and I called it B. So this point on the parabola and that point on the parabola. If I connect these 2 points, it makes a line. The average rate of change is the slope of this line. Okay? This line that's formed by the 2 points is called a secant line. That's the name of it. It's called a secant line. It comes from what you learned in geometry. Remember the one with the shapes class? Okay, when you talked about circles. A secant line is a line that passes through a circle. So it intersects the circle at 2 points. Okay, that was the definition of secant line that you first heard. So now we're just saying that a secant line is a line that passes through 2 points on a function, any function. And that line obviously has a slope, and we can calculate that slope. So now, how do we calculate slope? Well, the same way we calculated it forever. Delta y over delta x, y2 minus y1 over x2 minus x1. And here's a third way, or a third representation of the same thing. Maybe it's a little more interesting. I'll show you where it comes from. We use it in calculus all the time. F of b minus f of a over b minus a. So remember these 2 points that I put down on this graph here, A and B? Well, I can name these points with coordinates. So the x coordinate of this point is A, and its y coordinate, I'd have to take A and put it in up here for x, and I'd get f of A. Over here at B, I have a point B, f of B. So if I take these 2 points, A, f of A, and B, f of B, and I apply, let's say, delta y over delta x, or y2 minus y1 over x2 minus x1, well, I would get f of b minus f of a over b minus a. So it's the same thing. It's finding the slope. Okay? Just a different way to represent it. You see this one in calculus all the time, which is why we introduce it to you here in pre-calculus. Okay, so what we're going to do is we're going to go find the slope. Here we go. There are 3 ways to represent average rate of change. The first way is graphically. So the first thing I want you to do is I want you to find for me the average rate of change. Now remember, that means slope of f, this function, f of x, on the interval from x equals 1 to x equals 3. So you can see this parabola that's here. It's quadratic. Okay. At x equals 1, there's a point there, right? There it is. Okay, that point is called 1, negative 3. And at x equals 3, there's another point right here at 3, comma 1. Now, to find the slope, I need to know 2 points on the line, right? This is a line here. I need to know 2 points on the line. Well, I know 2 points on the line. Okay? 1, negative 3, and 3, 1. So I can find the slope. To find the slope, I do delta y over delta x, y2 minus y1 over x2 minus x1, f of 3 minus f of 1 over 3 minus 1. It doesn't matter. You can do it any which way you want. Okay? They'll all come out to be the same. So f of 3, that's 1. F of 1, that's negative 3 over 2. So that's 4 over 2. The slope is 2. And this is a graph, and there's a grid. You could count what's the slope of this line that I drew from this point. 2 up, 1 to the right. 2 up, 1 to the right. Rise over run. The slope is positive 2 over positive 1. It's 2. So the slope is 2 no matter how you do it. Okay? In this case, yes? With these two values. If I change the two values, if I pick two different values on this function, the slope definitely would, in some cases, you can see it definitely won't be 2 anymore. Right? If I picked this point at negative 1 and this point and drew the line, well, the slope's definitely not 2. Slope's negative. Okay, so just for these two values on this curve, I'm finding the slope of this line that I created. The slope of that line is 2. All right, that's the first representation. The second way to do it is algebraically. So I want you to find the average rate of change. I want you to find the slope. To find the slope, I need 2 points. Of this function now, it's not drawn for you. It's not graphed. On the interval x equals negative 1, x equals 2. To find the slope, I need 2 points. Well, I have 2 x values. They're not points, but they're x values. And I can find the y values that go with these x values by taking these x values and substituting them in to this function. So f of negative 1 would be 4 times negative 1 cubed minus 2 times negative 1 plus 1. So that's 4 times negative 1 plus 2 plus 1. Negative 4 plus 2 plus 1. Negative 2 plus 1. Negative 1. There's my y value. If I take 2 and substitute it in, I'd have 4 times 2 cubed, 2 times 2 plus 1, 4 times 8 minus 4 plus 1, 32, 28 and 1, 29. 229 is my other point. So now to find the slope, I could do delta y over delta x. I could do y2 minus y1 over x2 minus x1. I could do f of 2 minus f of negative 1 over 2 minus negative 1. So that would be 29 minus negative 1 over 2 plus 1. So that would be 30 over 3. It's 10. So the slope on this interval from negative 1 to 2, if I were to take these 2 points, graph them on this function, and draw the line, the slope would be 10. Okay? Or average rate of change. All right, finally, we have contextually. Okay? In context. So let's read this. The minimum wage in 1990 was $5 and in 2010 was $7.50. Find the average rate of change, that's slope. Okay, that's slope. In the minimum wage between 1990 and 2010. And then we have to give the units of measure. So I'll talk about that as well. So to find slope, I need 2 points. Well, I have 2 data points to work with. In 1990, the minimum wage was $5. And in 2010, the minimum wage was $7.50. Now the question is, can I find the slope with those 2 points? Well, yeah, of course I can. The slope would be $7.50 minus $5 over 2010 minus 1990, which is 2.5 over 20, which is 0.125. Okay. Now, 0.125, what? Well, what are the units of measure? Well, look at what you have. Look at what we calculated. In the numerator, it's $7.50 minus $5. So that's $2.50. In the numerator, it's money. In the denominator, 2010 and 1990 are years. Okay? So years is in the denominator. So what does it mean? It means the average rate of change here means that the minimum wage changed $2.50 over 20 years. Or we simplified this. We got 0.125. It changed by $0.125 per year, right? Because there's a 1 under here. You don't see it. We divided it out. So either way, this is a little more elegant. That's usually what we're looking for you to mark it down per year or per month or whatever it is, rather than over 20 years, especially if you can simplify. So it changed by 0.125 cents or dollars per year. That's what this means, okay? That's how you get the units for average rate of change. Look in the numerator. What are the units in the numerator? What are the units in the denominator? Well, then those are the units. That's the units of measure. All right, and that's it. That's how you calculate average rate of change. You find slope. To find slope, you have 2 points, and you know how to find slope with 2 points.